In this figure, we want to look at the Golgi tendon organ, and we want to compare it a little bit with the muscle spindles and their actions that we saw previously. Now, the Golgi tendon organ is a sensory structure, and it's found at the junction between the muscle belly and the tendon, right about here. If we blow that region up, we can see that the Golgi tendon organ is comprised of nerve endings embedded in this matrix of collagen fibers shown in blue here. Now, as the muscle contracts, it's going to actually generate tension and distort these collagen fibers. That in turn bends the nerve endings within which there are mechanically gated channels. This leads to a change in membrane potential and possibly an increase in action potentials that travel along this afferent neuron. And this afferent sensory neuron synapses in the CNS with an inhibitory interneuron shown here. That inhibitory interneuron subsequently synapses with the alpha motor neurons that control the motor units of this muscle, right? The extrafusal fibers of those motor units that are generating the tension. And so what that means is that as tension is being generated, we're activating this pathway, the Golgi tendon organ receptors, activating this pathway to actually inhibit the muscle that's generating that tension. And so what the Golgi tendon organ allows is modulation of muscle tension during development. Conversely, the muscle spindles, which are found in the muscle belly, shown here, they are actually sensing changes in length. They are more proprioceptive in telling us about the length of the muscle during a contraction or even during passive stretch. The Golgi tendon organ is not really activated by passive stretch because the muscle itself is much more elastic, right? The tendon itself doesn't really stretch much during a passive stretch of a muscle. It's more the muscle that's being stretched. And so only when the muscle contracts will the Golgi tendon organ become activated. Now, during a very strong contraction, this inhibitory interneuron can be strongly activated, tending to send much more dramatic output onto this motor neuron that is inhibitory, right? And if you think about it, right, during a conscious contraction, we have stimulatory input to activate this muscle, while the Golgi tendon organ is telling the same muscle to reduce its tension development. So it's really sort of modulating the contraction strength, but at very strong contractions, it's tending to shut off that muscle, helping us to avoid damage to the soft tissues here.